Welcome to the Radar Room, everyone. I am your tower director for today's session, and we are running a full-scale air traffic control exam emergency simulation. If you are operating in the Cambridge AS and A-level mathematics airspace, specifically Syllabus 9709, you are in exactly the right tower. Okay, let's dive into this. On our radar today, we have a massive incoming heavy aircraft. Its payload? Trigonometry. More specifically, the exact values of sine, cosine, and tangent for 30 degrees, 45 degrees, and 60 degrees. Now, in this explainer, we aren't just going to look at the raw numbers. We are treating this exam paper like a congested airspace under extreme time pressure, and we need to prioritize high-yield marks. To help us out, I've got two operators running the consoles today. Over on console 1, we have router Alex. Alex is brilliant but tends to get bogged down in minor details, creating an infinite holding pattern when trying to solve a question. Over on console 2, we have router Sam. Sam is the opposite, constantly trying to clear arguments for landing way too fast without verifying structural safety regulations. Our goal today is to find the perfect glide slope between Alex's overthinking and Sam's rushing, teaching you how to manage the intense pressure of the exam room and land every single available mark safely on the runway. Let's get this simulation initialized.
First things first, listen to this direct transmission we just intercepted from a senior examiner at Cambridge headquarters. Quote, "Mastering trigonometry, exact values of sine, cos, tan for 30 degrees, 45 degrees, 60 degrees is essential for Cambridge Mathematics AS and A-level 9709 success. This topic appears in every examination series." End quote. I need you to let that sink in for a moment. Every single series. This isn't a random weather anomaly. This is a scheduled daily flight. The stakes here are incredibly high because if you can't fluently recall that the sine of 30 is a 1/2 or that the tangent of 45 is 1, your entire calculation gets blown off course. But the beauty of this absolute certainty is that it's entirely predictable. Because it shows up on the radar every single time, mastering this specific theoretical area is essentially non-negotiable if you want that top-tier grade. It is a mandatory flight directive. But don't start sweating yet because I'm going to show you the exact flight path the examiners are looking for.
Here is our examiner's playbook for this simulation. First, core principles. Second, the procedural framework. Third, the method mark strategy. Fourth, top examiner mornings. And finally, evaluating for top marks.
Section 1. Core Principles, Building the Theoretical Architecture.
Okay, let's move to and see how this builds our foundation. Right now, router Alex is staring at the console, totally frozen, trying to memorize every single decimal variation of these angles. That is a critical error. The conceptual framework here isn't just about rote memorization, it's about structural integrity. The assessment objectives from Cambridge specifically target distinct cognitive domains. They're scanning your knowledge, your application, and your analysis. The theoretical architecture rests heavily on precise definitions and causal relationships. You see, the examiners are explicitly prioritizing analytical depth over superficial breadth. You absolutely have to know why these values are what they are. You need to be able to visualize an equilateral triangle sliced right down the middle to prove why the sine of 30 degrees or the cosine of 60 degrees operate the way they do. If you just memorize the final digits without understanding the causal relationships, the moment the exam throws a high-stress variable at you, your structural integrity collapses. You have to integrate this knowledge into your overall mathematical toolkit.
Now, what's really interesting about this slide is a massive radar blip we caught directly from the principal examiner reports. Candidates who reference cross-topic connections achieve significantly higher marks. What does that mean for you in the control tower? It means you cannot treat trigonometry as an isolated flight path. Router Sam is over there trying to answer a mechanics question and completely ignoring the trigonometric exact values hidden inside the vectors. Don't do that. Linking these exact trigonometric values to other areas of the syllabus, like calculus, mechanics, or coordinate geometry, gives you a massive competitive advantage. When you are asked to find the exact area under a curve in calculus, and your limits are 0 to pi over 3, knowing that the exact values of 60 degrees are going to pop out shows the examiner you understand the entire mathematical ecosystem. It proves you can track multiple intersecting flight paths at once without crashing.
Section 2. The Procedural Framework, Standardizing Your Attack.
When you are in that exam hall, the clock is ticking down, and you are under intense, extreme time pressure. Standardizing how you solve problems is the single best way to eliminate exam panic. I need you to look at this procedural framework as your strict approach vector. It is a reliable, repeatable sequence derived straight from the assessment criteria. Step 1. Deconstruct the question and extract the relevant data. Is it asking for an exact value or a decimal? Step 2. Select and apply the relevant analytical framework. Are you dealing with 30, 45, or 60 degrees? Step 3. Execute your analysis with crystal clear working. Step 4. Verify your results. Did you drop a negative sign in the third quadrant? And Step 5. Present the information in the appropriate format using correct terminology. Right now, Router Alex is stuck on Step 1, overanalyzing the question, while Router Sam is completely skipped to Step 5 and written down an unverified answer. Neither of them is going to land safely. Data interpretation skills here are absolutely critical. Following this strict 5-step sequence gives you total, undeniable control during a high-pressure data interpretation scenario. Never deviate from the glide path.
Section 3. The Method Mark Strategy, the ultimate insurance policy.
Tower transmission check. Hold your vectors right there. Before we clear this response for touchdown, ensure your transponder is updated. Subscribe to Ace the Exams, that's at Ace the Exams right now, and turn on all notifications so you never miss a critical exam update. Okay, transmission check complete. Let's resume the simulation. We are moving into the most crucial part of today's explainer. If there's one tactical secret that separates average students from the absolute top scores, it is mastering how method marks work. The method mark strategy is defined as earning critical examination points by explicitly showing your systematic processing and application of principles. Why does this matter? Because we all make mistakes under pressure. Sometimes the landing gear gets jammed. The exam framework heavily rewards the actual process of practical application and the demonstration of professional skills. What does that mean in an emergency? It means that even if your final calculation goes entirely wrong because you dropped a negative sign or misread a fraction at the very last second, your clear, systematic working can compensate and salvage the vast majority of the points. It is your ultimate insurance policy against total failure.
And this brilliantly illustrates the difference between our two operators. Router Sam loves scenario A. Sam looks at a complex trig equation, calculates it mentally, and just writes down the final answer. If Sam is wrong, 0 marks, a complete crash. But look at scenario B. Here, we encounter an unexpected structural block mid-paragraph. To get back on the glide slope, we deploy the Peel formatting template adapted for mathematics. P for point. State the exact trigonometric formula you are using. E for evidence. Substitute the exact values of 30, 45, or 60 degrees into your equation. E for explanation. Show the step-by-step algebraic manipulation. And L for link. Link it to the final requested format. By executing the analysis with clear working, even if your final answer is wrong, you salvage those critical method marks. There is a massive examiner alert in the source material specifically regarding this. Examiners consistently report that students needlessly hemorrhage marks by not showing their step-by-step working when dealing with exact values. Never rush blindly toward a final answer without documenting your flight path.
Section 4. Top Examiner Warnings. Navigating the Minefield.
Welcome to the Interactive Runway Workshop. I need everyone tracking this live. We've dug deep into the principal examiner reports, and we have spotted serious debris on the runway. These are the top 3 mistakes that will destroy your score. Number 1, confusing cause and effect. Number 2, forgetting to check format and presentation conventions. And number 3, providing answers that are not specific to the context given. Let's do a 60-second visual drill. Imagine an exam answer where a student correctly uses the tangent of 60 degrees as root 3, but they write their final answer in decimals when the question explicitly asked for exact form. Which regulation did they violate? Exactly, number 2 and number 3. Presentation of information follows strict conventions. Proper headings, exact radical formats, and clear annotations are just as critical as the math itself. If the airspace requires an exact value and you provide a rounded decimal, you are violating the runway constraints and you will lose the mark.
Before we move to the final high-yield strategy, I need to clear some cognitive bandwidth for you. Here is a rapid-fire tip directly from subject specialists. Create your own mnemonic for the exact values of 30 degrees, 45 degrees, and 60 degrees using the first letters of key terms. Find a memory hack that works uniquely for your brain. Maybe it's a hand trick, maybe it's a catchy phrase. But you need to ensure that recalling whether the sine of 60 is root 3 over 2 or the cosine of 45 is 1 over root 2 is absolutely instantaneous. By hardwiring these values into your immediate recall, you drastically reduce your cognitive load. It frees up your working memory to deal with the actual complex analysis of the question, rather than struggling just to remember the basic coordinates.
Section 5. Evaluating for top marks. The winning edge.
We are on the final approach vector now. Higher-order assessment objectives demand so much more than just basic descriptive skills. They demand rigorous, evaluative thinking, So the crucial point is understanding the traits of top-scoring candidates. They question assumptions. They consider different mathematical perspectives. They justify their decisions with solid algebraic evidence, and they identify alternative interpretations. In the Tower, we call this the fuel to mark budget formula. You need to budget your exam time based on the tariff of the question. If a question is worth 6 marks and involves exact values of 30 and 45 degrees, you cannot just spend 30 seconds writing a single line of working. You must evaluate your alternatives. Can you solve this using a double-angle identity? Can you prove it using a geometric diagram? Comparing approaches and evaluating the quality of your own evidence elevates your answer from merely showing a calculation to proving absolute, undeniable mastery of the theoretical architecture. This is how Router Alex and Router Sam finally log a successful full-mark landing sequence by balancing speed with meticulous, justified working.
As we conclude this emergency simulation, I want to leave you with one final, provocative thought to process on your radar. Are you rigorously evaluating your alternatives and securing those vital method marks through clear sequential working? Or are you just rushing blindly toward a final answer, hoping the landing gear deploys in time? Think deeply about your study habits. To truly master the exact values of sine, cosine, and tangent for 30, 45, and 60 degrees, you must completely submit to the analytical process. Practice past paper questions by applying this exact 5-step framework. Constantly hunt for those cross-topic connections, and never, ever skip showing your work. Before you log off the console today, I need you to execute one final command. Subscribe to ACE Exams, that's at ACE Exams, enable that notification bell, and leave a comment down below sharing which specific math paper gives you the absolute most anxiety. Thank you for joining me in the Tower for this explainer. Keep your vectors clear, and I will see you in our next deep dive.